welcome back Art22. Here we are again. Today we are talking about another way we can interact with our code, and that is by using the keyboard. So we've already seen that we can use our mouse to move things around the screen, to set it as the position for different shapes, but we can also use our keyboard as an input as well. And so this, you've seen this if you've ever played a 2D game, for example. We can use our arrow keys. So we're going to look at how we can set that up today, and we'll move some things around based on our keyboard. And we're also going to briefly touch on a different way we can control color with something called Hsb Hue Saturation Brightness. So we'll touch on both of those things, but for now, let us jump into the keyboard command section of today's lecture. So here we go. Okay, so let's get the normal things that we have in each sketch up and running. So we will have our setup section as per usual, and we will have our draw section also as per usual. Okay, now why don't we get a size in there for our window where we're going to be drawing our ellipse today. So let's go with 800 by 400. Again, somewhat arbitrary, and we know since we're going to be moving around this ellipse that we're going to need some variables for position. So why don't we go ahead and make some integers, x and y, that will be our variable for position. Cool. And let's also just set up where that initial position will be. And why don't we just go with the middle, because that's always a good place to start. So x will equal width divided by 2, and y is going to equal height divided by 2. All right, so got a size. We're starting position in the middle. Okay, great. Now, before we go in any further, why don't we go ahead and take a look at what we're going to be trying to draw here. Okay, so here is our screen. And there's our buttons. Okay. So once we actually draw this ellipse, what we're going to see is an ellipse pop up right in the middle of our screen at width divided by 2, height divided by 2. And what we want to happen, let's stick with the x direction, the horizontal direction, just for the moment. So what we want to happen is when we press the left and the right key on our keyboard, we want this ellipse to go left or right. So let's think about, I know we've touched on this briefly before, but let's think about again how we actually make motion happen. So we know that the width of our screen is 800 pixels because we specified that in our size command. So what is half of 800? It's 400. So we know that right now the x position of this ellipse from when we run our sketch at the beginning is going to equal 400. Width divided by 2 is 400. Now, if we wanted our ellipse to be 1 pixel over to the right, like this-ish, that means we've moved our position by 1 pixel to the right, which means x is now equal to 401. We've increased it by 1. So another way to think about that, moving right is adding numbers to x. So right is adding to x. And in the same way, if we were to move, let's say, 2 pixels back to the left, x is now 399. So left is subtracting from x. Okay? Now, what we're going to do today is set this up with our left and right keys, and then we're going to come back in a minute and think about how we can make it so that we get what you've probably seen in 2D games before with this kind of wraparound effect, where if we go off the screen to the left, we pop back out on the right side, or if we go off the screen to the right, we pop back over to the left side. But let's go ahead and get this first step implemented with just moving left and right based on our keyboard commands. So first things first, we are going to utilize another thing that processing has built in for us, which is it already has a function to detect when a key is pressed. So if we set up a conditional statement with an if, we say if key pressed turns pink, that is a good sign. And what that's saying is, hey, is a key pressed? All right, let's make some space here. Now, if that is true, then whatever happens whatever we put in the middle here between these two curly brackets, that will actually happen. So if we are in fact pressing a key, whatever we put in here is going to happen. Now, for different keys, there's different ways we can check. I guess a better way to say it is there are different ways to check for which types of keys we're pressing. The types of keys that we're working with today are a bit special in that they are like our arrow keys, things like the tab key, escape, things like that. So things that are basically aren't just letters or numbers. We have to treat slightly differently, but really all it means is one extra if statement. So here we are inside of our if key pressed if statement. And what we need to know is if the key we press turns pink again. So if this is the key that processing is detecting us pressing, if that key is a coded key. Now coded just means it's one of these special keys. It's an arrow, it's not a letter, it's not a number, that kind of thing. Okay, so if that's true, we'll give ourselves a little space here. So this is asking, is it a special coded key? All right. And if we're hitting the arrow keys, it will be, which means whatever we put inside here is going to happen. All right, so finally, we need to know which coded key we're dealing with. Which of these special keys is the one we're actually looking at? And so we decided that we're going to look at going left and right. So our left arrow and our right arrow. So why don't we first check for that right arrow? So if key code, so if the coded key that we have detected is right. Okay, so this is saying, is the coded key the right arrow? And if it is, we're going to do whatever's inside of here. Now, how did I know that I needed to capitalize all this? That is all available for us in the reference. So if you ever forget that, you can always go there and look it up. I've done it enough that I remember that coded and right and all the special keys are all capital. And you can see that they turn green, which is usually a good sign that processing recognizes what we're doing. For example, if I had put in lowercase right, nothing happens color-wise, and we see that down here we get this warning or this error. The variable right does not exist. So I'm like, something's wrong with that. If I were to look at the reference, I would know I need to make that all capital. Okay, so finally we've arrived at what we actually want to happen when we hit that right arrow. And we discussed that we need to add numbers to our X position so that we move over to the right. So why don't we say X equals X plus 1. Okay, and so this is, and I'm going to go ahead and introduce a little bit of a sneaky and more efficient way to say this, which is, we've seen it in our loops, but what is saying X plus plus. That is the same as saying X equals X plus 1. So when we say plus plus, that just means add 1 to whatever this thing is. So exactly the same as x equals x plus 1. If you'd rather have the clarity of seeing all this, no problem at all. It's just a bit more efficient and quick to write it this way. Okay. All right, so we've taken care of our right key. That's good. Now we need an if statement for checking our left arrow. So we can do the same thing. If key code equals all caps left. And let's put a comment in there. We'll say, is the coded key the left arrow? And if it is, then whatever we put in here will be activated. And so in this case, left, we want to subtract numbers from x. So we're going to say x, and you might have guessed it, minus minus, which is same as saying x equals x minus 1. So again, feel free to use either one. They are completely equivalent. It's just this is a bit nicer to write. Okay. Now, why don't we go ahead and check that this is actually working the way we hope it is. All right, so here's our ellipse right in the middle like we thought. Aha, there we go. I'm hitting the right arrow, moving 1 pixel at a time. I can hold it down and it goes. Boom, left arrow. Got the lamest 2D game known to man. And you know, one thing I do want to adjust before we go any further is it's kind of slow right now. I want a little bit more speed on this thing. So how could we do that? So we know that each time I click the right arrow, we are adding 1 pixel to its location, x plus plus. If I were to just add more pixels each time I hit the arrow, that means it's covering more distance with each arrow press that I do. So we can actually just add more to x. Instead of just adding 1, we could add more. So I'm going to show you again the kind of shortcut version for that. So now we're going to add 10 pixels to each time we hit the right arrow key. So this is equivalent, x equals x plus 10, to saying x plus equals 10. So anytime you see plus equals, it means add whatever's on the right to the left thing. So we're going to say x plus equals 10 is the same as x equals x plus 10. And now we can do the same thing for minus. X minus equals 10. That's going to subtract 10 pixels from the position. So it's going to move it 10 pixels to the left every time we hit our left arrow. Let's update that here. Okay, now let's see if we get something that's a bit more lively. Yeah, much better. All right, so now we're cooking a bit faster. Okay, and now as you can just see there, we kind of have this issue that we mentioned where if I just keep holding it to the right, it's going to go off the screen. If I hold it back to the left, it'll come back. But as we've seen in 2D games and other things, it's kind of nice to have a feature where it automatically just goes off the screen to the right and loops right back around to here. So let's take a look at what we want to do with that, and then we will implement that. Okay. So here is our screen yet again. We've got our ellipse. So as we're moving it over here to the right, when it's like right there, when it's starting to go off the screen, its position, when we know our width is 800 still, so its position right here would be something like 799. Okay. And once it gets off the screen, it means that its position is greater than our screen. So we know our screen is 800. So things are off the screen, the condition that makes that true, when x, our position, is greater than 800. Or another way to put it is greater than width. Okay, so this should help start to formulate how we're going to set up an if statement to make things always stay wrapping around our screen. So we know that the condition over here on the right side is x greater than 800 is like when we've gone too far. Let's think about it over here on the left side. When our ellipse is like right about there, we know that x is probably like 1, or maybe even 0. But when it's off the screen, that means it's less than the edge of our screen, which in this case we know we start from 0, so that means it's going to be less than 0. So x is less than 0. That's the condition for when we've gone out of bounds the other way. So we can formalize this, or put it in code, another way to say that, by thinking about an if statement in which we use these two conditions, when x is greater than our width and when x is less than 0. So let's start to think through that. So if x is greater than width, and we can kind of compress this all into one big if statement. Actually, let's keep them separate. So if x is greater than width, then what? So x is all the way over on the edge of our screen, and instead of just going off into infinity, we want it to wrap around to the other side of the screen. So what's the then part? So if it goes too far, if it gets greater than the width, greater than 800 in this case, what we want x to do is become 0. We want it to go to the other side of the screen. So if x is greater than width, then x is going to be reset to 0. And now we can just do the same thing, but for the other side. We can say if x is less than 0, then what? X is equal to width. So basically now, when we go off that left side of the screen, bumps over to the other side, which is width, or 800. Okay, so let's put that into our code. Okay, so we've kind of already got that sketched out, so let's just go ahead and implement that down here. So we needed to check on x in its relationship to the left and the right side of our screen. So if x is greater than width, so if it's 800 or more, or I should say if it's greater than 800, then we want x to equal 0. So start it at the left side of the screen. So if x goes out bounds on the right, reset to the left side of the screen. And now I'm just going to make life easy here and copy this, paste it again, do my little Command T to format that. So now we need to know if we go off the left side, so that is x less than 0. If we're going off out of bounds on the left, so when x is -1 or less, then we need to reset it to the right side of the screen, which would be width. All right, let's take a look at that. Okay, here we are. Ah, nice, okay. Very, very satisfying. Cool. All right, so our 2D game is not that much less lame, but at least we are keeping things in bound the whole time. And it's a little bit satisfying to watch this thing just loop around. Okie dokie. So the last thing I wanted to talk about today was this other color mode that we were talking about, Hsb. So previously we've been looking at RGB, red, green, blue, and how each of those was on a scale from 0 to 255. So 0, 0, 0 was all black, like our dot here, and then all 255 was white. And anything in between was some other color. Now, Hsb, Hue Saturation Brightness, is a bit of a different approach. So if we were to look at, this is a good example here. So here we have, actually let's start here. This is our hue. Starts at 0, goes all the way around 360 degrees. And as we go, we start to transition from reds, oranges, yellows, all the way back around until we're at 360, and then we get to 0, and we're at red again. Okay, now how about that saturation and value? So the, I should say hue is on a range from 0 to 360. Now saturation is how saturated that color is. So when it's at 0 saturation, that means there's really no color in there, right? So we're basically at white. As we go out and as our saturation value increases, that color is more maybe vibrant or saturated. Nothing like using the word in the definition, right? Okay, and then finally we have value, which is going from 0, which is the least bright. I'm sorry, in processing we use bright instead of value, but they're used interchangeably. And then when we get full brightness, full value, then we have our brightest version of that hue and saturation. So let us see how we can use that color mode in processing. So the first thing we need to do is tell processing we want to use a different color mode than the default RGB. So we use the built-in function color mode, and we tell it what color mode we want to use. Hsb, turn green, always a good sign. Okay, so use hue sat bright color mode. And just to make things nice, let's get a variable for each of those parameters, Hsb. So we'll say int Hsb. Well, these will be our color variables. Cool. All right, and now we actually need to use them. Well, actually, first we need to set them as something. So why don't we say in our setup loop, let's set our initial parameters for Hsb. So why don't we say hue is red? That's where things started. Hue. Let's give it a full saturation. So 360. Oops. 360. Fully saturated. And finally, let's also give it a full brightness value. Okay. And now let's replace our 0, so our black fill, in exchange for Hsb. And let's see what we get. There we go. There is our red dot, fully bright and fully saturated. Let's see if we were to change this to, how about 200? Cool. This nice purple color. So what I like about Hsb mode, and they each have their place, RGB and Hsb. What I like about hue, saturation, brightness is that, to me, it's a bit more intuitive. It's hard to see purple and know, just off the top of my head, what relationship of red, green, and blue do I need to incorporate to produce this color. However, it's much easier for me to know, or just to have an image of a color wheel and be like, oh, okay, so red's at the top, so 0. And just think about it as one parameter to keep track of, and then having my other two parameters deal with saturation and brightness. So let's see what this purple color would look like with less saturation and less brightness. So why don't we do like 60, 60 for those. yeah, so we lost a lot of that color and vibrance, but we're still technically in the purple hue space. Okay. Now, one last fun thing I'll do before we end today is, by virtue of having all these variables ready to go for position and HSB, we can start to mix these things around to get more complex behavior. And so let's take an example where, what if instead of just having a fixed hue for our ellipse, what if I wanted the hue to be associated with the position of our ellipse? So what I'm going to do is say, get out of here H, and I'm going to put X in. And let's see what behavior that gives us. Okay, so we are at red here. I'm just going to go left now. Aha. So now color is affecting our, position is affecting our color. And you notice if we go too far, we stay red, and that's because the max value is 360. So our X value, our position on our screen, is getting bigger than 360, so we're having no more effect. Later in the course, we're going to look at how we can use this function called map to put different numbers in the range that we want to use them, but we will get to that at another time. All right, so hopefully that gives you a bit of a taste of how interaction can be more rich than just the mouse. It can be with the keyboard, and also how we can start to fuse different elements of our code together. So now, not only are we just changing color and changing position separately, but position is now informing color. Or maybe if we were to change color, that would change the position. So there's all these relationships we can start to build in our code that will make things more complex, and I think just in general more interesting. So more on that to come, but that is all for today.